Okay, we're just continuing with exact values for the tan ratio, for the trig ratios for 30, 45 and 60 degrees. So just recapping on what we did last lesson, sine 30. If you can try and remember that one, just try and remember that one. Sine 30 is a half, it's the nice one. Now, from what we did yesterday, sine 30 equals which one? Which of these? Well, it's obviously not equal to sine 60. There's no way sine 30 and sine 60 would be the same. So sine 30 is the same as cos 60. So this is how I remember them. I say sine 30 is the nice one. It's a half, okay? So remember, you've got 30, 45, 60. We tend to start with sine, all right? So it's the nice one, a half. So if sine 30 is a half, so is cos 60. That's 2 out of 9 done. If sine 30 is the nice one, cos 30 is not the nice one, which is root 3 on 2. So notice they're both over 2. This is coming from that triangle with 1, 2, root 3. Do you remember that, how we did that? So if sine 30 is the nice one, it equals cos 60. Cos 30 is not the nice one. It's got the third. It's root 3 on 2. So cos 30 is the same as which one of these? Sine 60, root 3 on 2. Then with tan 30 and tan 60, see the tan 30, it's got the 3. But tan 30 is smaller than tan 60. That is the 1 on root 3. Tan 30 and tan 60 are very similar. What's this one? This is root 3 on 1 or just root 3. See, 30 is smaller than 60. If you do 1 divided by root 3 on your calculator, you'll get a smaller number than root 3. So the fraction one's smaller than the root 3 one. That's how I remember them. So tan 30, it's got that 3. 1 on root 3 because 30 is smaller than 60. That one's root 3. So if you remember sine 30, so really you're just remembering probably these. If you remember these 3 here with the 30s, you're automatically knowing cos 60. You're automatically knowing sine 60. And if you know this one, then the tan 60 is the flip of that one, right? So learn these 3, right? Now, sine 45 and cos 45 are the same. They come from that right angle triangle with sides 1, 1, root 2. Do you remember what sine 45 is? 1 over? Well, sine 45 and cos 45 are the same, and we're going to cement that today because the next exercise we do looks at the relationship between sine and cos. And we can already see some of that relationship already because sine 30 equals cos 60. 30 and 60 add up to 90. Cos 30 equals sine 60. They're the same because 30 and 60 add up to 90. What we say is that sine and cos are complementary ratios. Like complementary angles add up to 90. These are complementary ratios. So I could say cos of 10, and that would equal sine of what? Cos of 10. Sine of 10 and what makes 90? Yeah, that's what we're going to do later today, all right? And notice sine and cos are complementary. 45 and 45 add up to 90. All right? Tan 45 is a really nice one. And what is it? Right. The nicest of the lot. All right. So remember, if you forget these, you can put them in on your calculator. If you get a nice answer, you write it down. And if you get a decimal, you square it and then you square root it back. Okay? All right. So there's your ratios. Question 6b, find the exact value of. Now, this is 1 minus 2. Sine squared 60 means sine 60 times sine 60. Now, what's sine 60? It's root 3 on 2, and I square that. Okay, so what do you remember about a square root and a squared? They're opposites. They're inverse operations. So this is 1 minus 2 times root 3 squared. You can do it on your calculator if you want. You get 3 because you don't actually have to know what root 3 is, girls. All right. Here, square root of 3 squared, square root and squared are inverse operations. That just equals 3. So square root of 3 squared is 3. 2 squared is 4. Now, this is 1 minus 2 times 3/4. What's 2 times 3/4? What can I do here? You can do it on your calc, or you can start. Should I do the 1 minus 2 first or the 2 times 3/4 first? Yeah, so can't you cancel and go 1 up here and 2 down there? It's basically 1 minus 3 on 2, or just get your calculator out if you want. So it's 1 minus, if I cancel the 2 and 4, I get 1 times 3 is 3 over 2. Girls, this is 1 minus 3 over 2 is 1 minus, what's 3 over 2? 1.5. What's 1 minus 1.5? Negative a half. That's what you should get. Now, if you could actually just do that question on your calculator if you wanted, but we're trying to get you to remember the exact values. All right? So the next one, 4 times sine squared 45 plus cos squared 45. So that's 4 bracket. What's sine 45? 1 on root 2. I've got to square that. Plus 1 on root 2. I've got to square that. And it's 4 times. So notice I'm putting 4 bracket 1 over root 2 in brackets squared. I'm going to get rid of these squares. What happens if you square 1 on root 2? What do you get? See here, you've got to square the numerator. 1 squared is 1. What's square root of 2 squared? Girls, square root of 2 squared, the square root and the squared cancel, and I get 2. Plus, what's 1 over square root of 2 squared? 1 squared is 1. Square root of 2 squared is 2. What do I do here first? Big maths. A half plus a half is? So 4 bracket means 4 times 1, which is? Okay. Sine 45 is 1 on root 2. Remember, we're just using, and that's sine squared 45, so it's sine 45 squared. Okay? What we're trying to do here is you practicing those ratios. In other words, you've got to learn the 9 of them. 1 minute. Question 7. Simplify the following. Give exact answers. Tan 45 divided by tan 30. I'm actually not going to write them over each other because sometimes you get fractions for some of these. So I'm just going to say, well, that's really tan 45 divided by tan 30. You okay with that? Reason I'm going to do that is tan 30 is a fraction. So we've got tan 45, what's that? Divided by tan 30 is the one with the 3's, 1 over root 3. How do you divide by a fraction? You change the divide to a times and you flip root 3 over 1. Oh, everything's rocking. So 1 times root 3 over 1 is, 1 times root 3 is root 3. And you've got a 1 on the bottom. This one, cos 30 divided by cos 45. That's cos 30 divided by cos 45. The reason I'm doing this is that I know they're both fractions. Most of these ratios are fractions. So what's cos 30? See, sine 30 is the nice one. Cos 30 is not. Yeah, root 3 over 2 divided by, what's cos 45? Okay, very good. Okay, now, this is something that you sort of haven't learned how to do. So, root 3 over 2, change the divide to a times, and then flip. Now, I'll just tell you the rule now. See how the 3 is under the square root sign, and so is the 2. It's also under the square root sign. That is the same as putting them both under the square root sign. And you can see how they're both under. They're not both whole numbers. They're both under the square root sign. So the square root of 3 times the square root of 2 is the square root of 3 times 2. On the bottom, I've just got a normal 2. What's 3 times 2, girls? So it's just the square root of 6 over 2. Now, I know you haven't learned how to multiply surds, but that's what you do. So, for example, if I had, for example, over here, square root of 4 times square root of 5, what's that? Square root of? Yeah, that's the rule. I'll just give you another example of multiplying surds, even though you haven't done them. 2 root 3 times 4 root 5. Just an example. Girls, this is multiplying surds. You haven't learnt it, but it's very easy. You multiply the whole numbers. That makes sense, doesn't it? 2 times 4, because they're whole numbers, is 8. And the square root of 3 times the square root of 5 is the square root of 15. So when you're multiplying, these are called surds. You just multiply the whole numbers, multiply the surd bits. Does it make sense? All right. Solve these equations for 0 less than theta less than 90 degrees. What it's telling you is that isn't that an acute angle between 0 and 90? So your answer's got to be between 0 and 90. You're going to understand why I'm writing this later in the week. Not now. So tan of what? This is just a memory game. Tan of what is root 3? Is it 30, 60 or 45? That's that. Done. Okay. The next one. Cos of what is a half? Is it 30, 60 or 45? Good. Oh, didn't want them all to be 60. Notice I don't need much room. And tan of what is 1? That's it. That's how you solve those. So girls, you can if you want. How else could you do it on your calc? Don't you go, the way you used to do this was like this. Do you remember? Before you knew about the exact values, if I give you tan of theta is root 3, you would have gone shift tan to the -1, you know, root 3, and do it, and you will get 60. For this is what you used to do on your calculator. Do you remember that? If I give you cos theta is a half, you used to go inverse cos a half, and you would have got 60. Got it? That's on the calc. But now you will recognise, you should be able to recognise any of those with the exact values. Get what I'm saying? And if you don't, you can still use your calculator. All right? If you were to do this one on your calculator, you would have been doing this before. In other words, this is a bit of a time saver if you know your ratios. See, when you see tan theta is 1, you don't go tan to the -1 of 1. If you did do it, you'd get the 45. That's on your calc. These are all on the calc. But you don't need a calc for those. You're supposed to remember them. These were question 9. Now for question 10. So they're the sorts that you're expected to know off by heart, but even if you didn't, you could still go to the old method of doing it on your calc. Okay, question 10, 10b. Find the exact value of the pronumerals. Okay, when you see this, how would you normally do this question? Is it sine? Yep. Opposite, hypotenuse. So it's definitely sine. Sine of 30 equals k over 10. So doesn't k equal, what do I do? Times, divide, what? K divide by 10, opposite is? So sine of 30 times 10. Now you could do it on your calculator, but sometimes it's longer to do it on your calculator. What's sine of 30? So therefore this is a half times 10. So therefore k is 5. That's it. So really, this exercise is just about you remembering 30, 60, 45 degree ratios for sine, cos and tan. That's all it is. Nothing really is new. I know there was that bit of surge thing, but it's mainly just getting you to remember those ratios. And it's really important that you remember them for, you'll do them again in year 11 if you're doing mathematics or extension, but you're expected to know them pretty quickly, okay? This one, sine, cos or tan. Well, I don't have the hypotenuse, so that's opposite and that's adjacent. Opposite, adjacent. So tan of 30 is u over 6. How do I get the u on its own? U equals, so that's u divided by 6. So it'll be tan of 30 times 6. What's tan of 30? What's tan of 30? 1 over times 6. Now, 1 times 6 is 6. That's really 6 over 1. Tan 30 is 1 on root 3 times 6. When you're multiplying fractions with whole numbers, you can write the whole number over 1, multiply the numerators, multiply the denominators, 6 over root 3. Now, in mathematics, we actually don't like to leave, you know how we don't like to leave improper fractions? We don't like to have square roots or surds on the denominator. So do you remember how I get rid of that surd on the denominator? I times the numerator and the denominator by that surd, both by root 3. Do you remember that yesterday? So I've got 6 over root 3. I know root 3 times root 3 will give me a whole number. What will it give me? 3, that's right. So if I decide I'm going to multiply the denominator by root 3, I must multiply the numerator by root 3. Why? Because root 3 divided by root 3 is just 1. I'm only changing how this fraction looks. So what's 6 times root 3? 6 root 3 over root 3 times root 3 is 3. What do you think I divide here? You know how we were multiplying whole numbers before? You would divide the whole number bits. What's 6 divided by 3? So it's 2 with a root 3 on top. So 6 over 3 is a 2 on the numerator, and then just put the root 3 next to it. And that brings me to doing something like this, a little skill check. Let's say I had 6 root 10 over 3 root 2. See if you can work out what to do here. Oh, no, it's divide. So divide the whole number bits. You know how I just did this with multiplying? Same rule with dividing. What's 6 divided by 3? And what's square root of 10 over square root of 2? 5. Square root of 5. So you divide the bits under the square roots, or I could write it like this, put them under the square root together. Do you get it? So 6 divided by 3 is 2, and both of these are under square root. So I'll put them both under a square root, 10 over 2. What's 10 divided by 2? 5. That sort of rule with thirds really makes sense, but I will make sure, because you haven't done this topic yet, that you won't get one like that in this exam. But you will later in the year. Okay, once you've learnt thirds.